The comprehensive rewrite of all sciences. A unified fractal theory of everything. Expanding the role of magnetism across disciplines. Cosmology and magnetism. Cosmology and magnetism. Fractal proof. Intergalactic magnetic fields exhibit self-similar patterns across vast cosmic scales. These fractal structures influence the distribution of matter and the formation of galactic filaments, as seen in the cosmic web. Evidence. The Planck satellite observed magnetic fields following the fractal-like distribution of dust grains, implying a universal scaling behavior in cosmic magnetism. Explanation. Magnetism organizes matter hierarchically, forming recursive patterns that resemble fractals. These patterns provide stability to cosmic structures, while dictating the flow of plasma and matter over billions of light-years. Intergalactic magnetic fields. Research indicates magnetic fields exist across galaxy clusters and cosmic voids. These fields could explain the large-scale structure of the universe, acting as organizational guides for dark matter filaments. These magnetic fields may also contribute to cosmic microwave background, CMB, anisotropies, challenging isotropy assumptions in cosmology. Fractal magnetism. Magnetic field alignments in star formation regions suggest fractal patterns influencing galactic evolution. This fractal organization might be crucial in shaping both visible and dark matter distributions. Biology and magnetism. Bioelectromagnetic fields. Nerve impulses rely on ionic flows, generating measurable electromagnetic fields. Biology and magnetism. Fractal proof. Magnetoreception in birds and other organisms demonstrates how biological systems utilize Earth's magnetic field. These magnetic field lines exhibit fractal fluctuations that align with migratory behaviors. Explanation. Biological systems rely on fractal dynamics in magnetism to maximize efficiency in processes like migration, molecular orientation, and cellular communication. Evidence. Research on avian navigation shows sensitivity to fractal magnetic field changes, critical for long-distance travel. These fields might serve as fractal resonators, connecting biological systems to larger cosmic patterns. For example, the human heart's electromagnetic field could interact with external magnetic phenomena. Magnetoreception in animals. Studies of migratory species using Earth's magnetic field for navigation suggest evolutionary integration of magnetic fields, which may extend to cellular processes such as DNA repair influenced by geomagnetic activity. Unified electricity magnetism in quantum mechanics. Electromagnetism as a fundamental interaction. Fractal proof. Electromagnetic waves show fractal properties in their propagation through disordered media, such as atmospheric scattering or cosmic dust. Evidence. The scaling laws governing electromagnetic waves in chaotic systems match fractal equations, suggesting self-similarity. Explanation. Electromagnetism bridges quantum and macroscopic systems, forming fractal structures that optimize energy transfer and information flow. Quantum spin and magnetism. Quantum particles exhibit spin, influenced by magnetic fields. This spin behavior aligns with fractal dimensions in particle-wave duality, potentially linking quantum behavior to cosmic magnetism. Electrodynamics in higher dimensions. Magnetic and electric fields interact in ways suggesting higher dimensional origins. Magnetic monopoles, if detected, could reveal deeper interactions within fractal field structures. Practical application. Fusion energy. Magnetic confinement in fusion reactors relies on advanced electrodynamic principles. Incorporating fractal-based field theories could improve energy stability and yield by optimizing plasma flow within fractal magnetic pathways. Electromagnetic propulsion. Develop propulsion systems using fractal magnetic fields to enhance thrust efficiency for interstellar travel. Thermodynamics and entropy as fractal processes, redefining entropy. Fractal entropy and energy transfer. Entropy increases in predictable patterns that mirror fractal systems. Fractal proof. Entropy dynamics, especially in turbulent flows or black holes, follow fractal scaling laws. Event horizon area calculations suggest fractal geometry at quantum scales. Evidence. Studies of turbulence and black hole thermodynamics reveal fractal dimensions in entropy distribution. Explanation. fractals enable entropy to maximize disorder while maintaining efficiency, ensuring the stability of systems from molecular dynamics to cosmic evolution. In complex systems, such as black holes, entropy manifests as recursive scaling where Hawking radiation encodes information in fractal geometries. This recursive process links thermodynamics to quantum information theory. Energy cascades across scales. Thermodynamic processes, from molecular motion to galaxy formation, follow fractal pathways, optimizing energy distribution and minimizing waste. Thermal resonance and cosmic heat death. Heat flow in fractal systems. Energy dissipation across dimensions suggests thermal equilibrium is reached nonlinearly, contradicting the classical heat death model. Instead, localized systems may persist in fractal hotspots, where energy concentrates at specific scales. Quantum thermodynamics. Heat exchange at the quantum level involves fractal oscillations that could reveal pathways for energy regeneration within closed systems, challenging the second law of thermodynamics. Application. Fractal-based engines. Develop engines that harness energy more efficiently by optimizing fractal pathways for heat dissipation. These engines could revolutionize spacecraft efficiency. Heat pumps in fractal systems. Design thermal devices that utilize fractal patterns for maximum efficiency in energy transfer, reducing energy waste in industrial systems. Consciousness and quantum mechanics. Consciousness as a fundamental force. Fractal proof. Neural networks in the brain exhibit fractal connectivity, optimizing information processing. Plasma structures in space mimic this neural self-similarity. Evidence. EEG studies of brain activity confirm fractal-like patterns in neuronal firing rates. Explanation. Fractals underpin the self-organizing behavior of consciousness, whether in biological or cosmic systems. Magnetic field consciousness links. Neural electromagnetic fields could act as fractal resonators, linking human consciousness to quantum fields. These links might explain collective human behaviors influenced by geomagnetic activity. Quantum fractals in decision-making. Consciousness operates as a fractal quantum process, exploring probabilistic outcomes at multiple scales, potentially linking free will to quantum uncertainty. Research directions. AI fractal consciousness models. Build AI systems using fractal-based algorithms to simulate nonlinear decision-making. These systems could help predict and model collective human behavior. Neural holography. Investigate whether the brain encodes memories and decisions holographically, using fractal patterns to optimize information storage and retrieval. Counterarguments and challenging current models. Big Bang limitations. Fractal proof. Cosmic microwave background, CMB. Radiation fluctuations show fractal-like anisotropies, challenging the uniformity implied by standard Big Bang models. Evidence. Analyses of CMB patterns by the WMAP and Planck satellites show fractal scaling. Explanation. Fractals suggest the universe might not have originated from a singularity, but evolved from a recursive process of cosmic inflation. Contradiction. The Big Bang assumes isotropy, while cosmic anisotropies like the CMB cold spot contradict it. Proposal. A fractal cyclic model of the universe explains localized anisotropies as multiverse interactions, where each cycle retains imprints from its predecessors, creating observable, memory, anomalies. Abiogenesis challenges. Contradiction. Abiogenesis experiments fail to replicate complex molecule formation in controlled conditions. Fractal proof. The chemical pathways leading to life exhibit fractal branching, such as in autocatalytic cycles or molecular self-assembly. Evidence. Experiments simulating prebiotic conditions show fractal clustering in early organic compounds. Explanation. Fractals provide the structural foundation for abiogenesis, enabling complexity to emerge from simplicity. Proposal. Molecular self-assembly follows quantum fractal patterns, influenced by cosmic electromagnetic fields. Testing these patterns in simulated quantum environments may yield insights into life's origins. Technological horizons. Advanced magnetism applications. Fractal proof. Magnetic nanoparticles and fractal-based antenna designs improve energy efficiency and signal propagation. Evidence: fractal antennas show enhanced performance in chaotic environments, such as in deep space communication. Explanation: fractal geometries in magnetic devices optimize performance, making them ideal for advanced applications like quantum computing. Magnetogravitational energy systems develop devices that exploit interactions between magnetic fields and gravity to create energy. These systems could harness Earth's geomagnetic activity for sustainable power. Electromagnetic medical diagnostics use bioelectromagnetic imaging for advanced, non-invasive diagnostics, such as detecting neural disorders through fractal analysis of brain waves. Thermodynamics applications. Quantum heat pumps use fractal patterns to design highly efficient heat transfer systems for industrial and space applications. Fractal proof. Heat transfer in materials follows fractal scaling laws, with branching structures improving efficiency. Evidence: fractal-inspired designs in heat exchangers demonstrate superior performance. Explanation: fractals maximize thermal transfer by reducing resistance and increasing surface area, critical in energy systems. These pumps could drastically reduce energy consumption in extreme environments. Cosmic heat redistribution. Explore ways to harness intergalactic thermal flows as energy sources, using fractal field manipulation to capture and direct heat energy across vast distances. Entropy harvesters develop technologies that convert entropy gradients in large-scale systems into usable energy, potentially reversing localized entropy to sustain closed ecosystems. Additional mind-bending topics. Gravity as an emergent phenomenon. Fractal proof. Gravitational lensing around massive objects shows fractal-like distortions, hinting at recursive behavior in space-time curvature. Evidence: simulations of black holes reveal fractal patterns in their gravitational influence. Explanation: fractals suggest gravity may emerge from the collective behavior of quantum-scale interactions, scaling up to cosmic levels. Hypothesis: gravity arises from entropy changes in space-time, linked to fractal thermodynamic processes. Proposal: study the relationship between black hole entropy and surrounding gravitational fields for evidence of emergent gravity. Time as a nonlinear continuum. Hypothesis: time operates as a fractal dimension, creating loops and branching timelines. Fractal proof. Temporal dynamics in chaotic systems, such as weather patterns or quantum processes, show fractal scaling. Evidence: time series analyses in nonlinear systems reveal fractal-like structures. Explanation: fractals unify linear and nonlinear aspects of time, allowing for the possibility of loops, echoes, and alternative flows. Proposal: examine closed time-like curves in extreme gravitational fields for fractal time behaviors. Dark energy as quantum resonance. Hypothesis: dark energy results from quantum field fluctuations creating fractal resonance across the universe. Fractal proof. Dark energy distribution in the universe correlates with the fractal geometry of the cosmic web. Evidence: observations of large-scale structures align with dark energy models predicting fractal scaling. Explanation: fractals explain dark energy's role as a quantum resonance, distributing itself uniformly yet self-similarly across the cosmos. Experiment: observe cosmic expansion anomalies for oscillations consistent with quantum fractals. Fractals offer a unifying principle that connects seemingly disparate phenomena across all scales, from quantum mechanics to cosmic evolution. These recursive structures provide a mathematical and physical framework that explains the efficiency, complexity, and interconnectedness of the universe.